Okay, so putting it all together, we're trying to talk about the phase diagrams. Phase diagrams are the diagrams where we have temperature, pressure uh, for a sample over the wide range and showing different phases, solid, gas, and liquid. Depending on where you have on the temperature to pressure, is going to tell you that the substance is going to be either in the solid form, liquid form, gas form, or it's going to be a triple point. We'll see what is triple point, or it's going to be the liquid is going to be at the critical point. Okay, so it combines the plots of pressure versus temperature for the liquid, gas, solid, liquid, and solid gas phase transition equilibria of a substance. This is used to predict what is going to happen. Okay, it indicates the physical state that exists in the specific condition of pressure and temperature, and also it details about the pressure dependence of the phase transition temperatures. Okay, so we can look at different things like what is going to be the melting temperature, the freezing process. Okay, sublimation point, where is going to be the sublimation point, what conditions you need to have for example to sublimate, deposition, vaporization, condensation, and all that stuff. So it's pretty easy and not that difficult if you look at it. So what we are looking at here is the phase diagram of water, where you see a negative slope between the transition from solid to liquid. We know that the water is denser in its liquid form than ice, and that's why we have this negative slope here. Special, it's so special to the water sample. Okay, that's it, because of this unique property of water. So we have triple point. If we keep the temperature at, we see how low temperature it is and how low pressure it is. We can actually have it at triple point. What is triple point then? Triple point is where the sample exists simultaneously in all three forms of states of the physical states. Critical point is where the sample is difficult to be identified as either liquid, solid, or gas. There's specific applications that scientists have used by keeping the samples at critical points. We're not discussing those examples, but know that the critical point is a good measure to do so many applications with that sample, in order to do so many things for that particular sample. Concept check is where you have to figure it out at what condition, what is what. Okay, so using the phase diagram of water, determine the state of water at the following temperatures and pressure. So minus 10 degrees Celsius, which is going to be approximately somewhere here, and then 50 kPa, which is going to be here. The water is going to be in the water form, liquid form. So that's going to be the liquid. At 25 and 90 kPa, it's still in the liquid right here. This is approximation. So it's going to be liquid at 40 kPa, 40 kPa, and 50 degrees Celsius. So 40 kPa is going to be somewhere here, not half, but less than half. And then it's going to be 50 degrees Celsius. So it's still in liquid. 80 degrees Celsius, you're going to become closer to that, and 5 kPa, which is going to be somewhere here, that is where it's going to go into the gas. Okay, so you can just figure it out by looking at these things and approximated it by. So this is for the carbon dioxide, the positive slope here. So temperature dependence and the pressure that we are looking at the same way. So what state exists at 480 m and 70 K? So the 480 m is going to be this one. This is 2. So the 2 is going to be here. Then the 4 is going to be here, right? So 4 and 70 is going to bring it to the liquid form. Solids. Okay, so the last thing is about the solids, introduction to the solids that we are trying to do, and I'm going to do it in a short video after this one.